Alright, welcome to a one shot where everything's done in one take. Today I will be explaining how to graph and solve kind of polynomial functions as well as rational functions. And yeah, no edits, no anything if I mess up, oh well. This time we'll be looking at the equation of, what does that say? X by x minus 2 by x minus 3 by x minus 1. First off, you want to find the degree, which is done by adding up the exponents of the x's, which in this case would each be 1 because of the fact that there is no exponent either on the outside or explicitly stated to be next to the x. So in this case there are 4 x's, so the degree, when you multiply 4 or x by itself 4 times, would be a degree of 4, meaning that would be x to the power of 4, since there are 4. That's a lot of 4s. I think I said that like 4 times. Ha ha ha. Anyway, leading term or leading coefficient, depends on whatever you want to call it, is based on if there were to be any numbers in front of the x. Now in this case we all have the invisible 1, so the leading term in this case would be 1. The end behavior is based on the whether the leading coefficient, I'm going to be calling it the leading coefficient even though it says leading term, whether the coefficient is positive or negative, and whether the degree is an even or an odd. In this case, since the degree is even and the leading term is positive, the end behavior will be up and up, meaning that that's how the graph will turn out, going up on one end and up on the other. Also known as increase, probably not, but this is basically what it is. The zeros are found by whatever ends up making, whatever turns this entire function into 0. So plug in 0 here and figure out what it would be for each x. So for this x, since it is just the x on its own, it would be 0, 0, aka the origin. For this one, since it is a minus 2, the only way to make this 0 is to add 2. So your coordinate would be 2, 0. To make this one 0, you needed 3 for similar reasoning, but with a 3 instead of a 2. And then here, since it's supposed to be 1, on the video it doesn't turn out that way. Anyway, this is supposed to be a 1, or negative 1, better said. So same thing applies. So your 0 would be 1, 0. And if you're noticing the erase mark, it's because my phone died when I was recording the first time, so it's kind of late and I'm just tired. Now, in order to graph, you want to place about where your zeros would be. And there's one thing I didn't mention, which is based on the multiplicity, and the reason why for this one at least, but you're going to need it to know it later, is based off of the, again, multiplicity of each thing based off the exponent, whether it's positive or negative. Or, sorry, not positive or negative, but 1, even, or odd. If it's 1, it just crosses with nothing special, so to speak. If it's even, it's referred to as tangent, but the way you show it is that it bounces off, sort of makes a curve. So it like that basically. Man, this eraser is terrible. Anyway, and if it were to be any other odd, it would basically like wiggle, kind of. It would basically turn out like this. Yeah, close enough. You know what I mean. It looks kind of like a snake. Anyway, I'm getting off topic. Now, since we established that it would go up and up, that means that it goes from the origin up and from 3 here up. And since the multiplicity of all of these is 1, they would all cross. So at the origin, hang on, let me just reposition the camera. At 0, it would cross, go back to the graph at 1, go back to the graph at 2, and go back to the graph at 3. And bada bing, bada boom, that is your graph for polynomial functions. Dang, phone, focus. Alright, now for rational functions, I actually didn't get to finish this one last time. But in order to calculate this, you're going to need to find the following. The domain, the vertical asymptote, which is what VA stands for, a hole or point of discontinuity, the horizontal asymptote, the x-intercept, and the y-intercept. Now, the way you want to factor this is, I already have it done here, so I'm just going to write it. It turns into x by x plus 3 over x plus 3 by x plus 2, or x minus 2. God, that looks awful. Anyway, basically the domain is based off of whatever in the denominator is made 0, like in the polynomials that I mentioned about a minute ago. So in this case, it would be -3 and 2. So that's where your horizontal asymptotes would be at x is equal to -3 and at x is equal to positive 2, since that is supposed to be a -2. So the domain would be -infinity to -3. I don't know why you have to draw a u, but draw the u. It's supposed to be like and, but at the same time, anyway, -3 to 2, another u, and then 2 to infinity, since it's supposed to be like all real numbers except for the vertical asymptotes, the x values for the vertical asymptotes. Points of discontinuity are found through a common factor between the numerator and denominator, which in this case would be x plus 3. So you basically try to get rid of that, and you're left with x over x plus 2. Or, sorry, see, this is why you try writing it right first time. X minus 2, sorry. And in order to calculate what the point of discontinuity would be, you plug in the 0, or the root, for the common factor, which in this case would be -3. So this turns into -3 over -3 minus 2, which is -3 over -5, which would transition to the whole being, with the 0 being 3, or with the x value being 3, sorry, since that's the 0, or root of the common factor, this thing. And then the y value would be -3 over -5, which translate into being 3 over 5. Just write that little negative there. Now, the horizontal asymptote, in this case, is based off of the rule eats dc, which is exponents are the same, divide coefficients, which is basically, since these two both have the same exponent, you divide their leading coefficient, which in both cases is 1. So 1 divided by itself means that the horizontal intercept is at or horizontal asymptote, sorry, is that y is equal to 1. Now, to find the x-intercept, you plug in 0 for the numerator. So basically whatever the zeros are for the numerator, which in this case are the origin, once again, and the -3, 0. Now, you're probably thinking to yourself, how would it be able to touch the x-intercept if the vertical asymptote is on the same x? Well, my dear viewer, there's a weird rule with the point of discontinuity. And that is that nothing can exist on its x value. So, in this case, since the x value is at -3, there can be no vertical asymptote at x is equal to -3, and there can be no x-intercept at x is equal to, or at -3, 0. So that just leaves us with the origin and one vertical asymptote. Now for the y-intercept, you basically set the whole thing to 0. So, well, actually, you get rid of any x's. You see? So, x plus 3, or 0 plus 3 times 0 is 0. And that just basically makes this entire thing mute because you're dividing something, or 0 by something, which is equal to 0. So you're left with only the origin as your y-intercept. So you graph that here. You have your little vertical asymptote at 2. And now you're probably wondering to yourself, how am I supposed to graph this? Well, you still have your horizontal asymptote, which should help. And don't forget to try and get your point of discontinuity, which is about here-ish and about here. So leave this circle here. And to not waste too much time, if it basically just turns out like this, your most likely outcome, assuming that there is a point of discontinuity and there is an x-intercept at the origin, is based off of, like when it's like this, you basically have the line or go through the point of discontinuity. You ignore that part altogether. Go through the x-intercept and then stay with the vertical asymptote. And the same has to apply here. Start that here. Basically that, because of the fact that they can't touch, there's basically, there's only one situation where they would probably go the exact same direction, and that's slipping my mind at the moment. So this is how you would graph this rational function altogether, and you use similar methods with any other rational function. There are minor differences, like some having, when you have two vertical asymptotes, the lines get really weird. No headphone cable. Bad. And yeah, that's how it's done.